Tuesday? Well, like, because
When we are looking at a non-right triangle, there's two different laws that we can use. One of them being called the law of cosines, and the other one is the law of sines, and we're going to cover both of those today. Okay? So notice that this triangle here is not a right triangle. Okay? When we don't have a right triangle, we can find the missing angle by using this formula, and you can write this on your paper. Little c squared equals little a squared plus little b squared minus 2 little a little b cosine big C. Okay? So this one being the angle C. These being sides. All right? Let's move down. The law of cosines can be used to find a measure of any angle of the triangle if the measure of all three sides are known. Okay? So, in other words, if I'm looking for an angle of the law of cosines, I can rewrite this law of cosines by solving for cosine C. So remember, if I have c squared equals a squared plus b squared minus 2ab cosine big C, I can solve for just the cosine C. How do I do that? Yeah, get everything on the other side. So I'm going to subtract an a squared from both sides, subtract a b squared from both sides, and then I would divide by 2ab. Okay?
Wouldn't it just make more sense to like just divide both sides like a number?
Okay. Did you solve your question?
Yeah.
Okay. So if I subtracted a and b and then divided by negative 2ab, that would equal cosine C. Do you guys see the algebra of how I did that? How would I find the angle once I got to this point? Inverse cosine. Good. Yep, I'd have to take the inverse cosine. Okay? All right, so moving on, let's look at this problem right here, an example. We have a triangle with a side 5.3, 6, and 8. Okay? And it wants to find the measure of its largest angle. Which one do you think is the largest angle? C. So we're looking for this angle right here.
You just eyeball it?
The largest side. Yep. So if you look at the largest side, 8 is opposite of C, so C would be the largest angle. Okay? So on this one, if I were to go through and actually use this part of the formula, okay, little c is 8, okay, because that's the side opposite of C. This one's little a, it's opposite of big A, and this one's little b, okay? So I'm going to go through and actually put in these numbers. So it'd be 8 squared minus 5.3 squared minus 6 squared. That's going to be over minus 2 times 5.3 times 6.
Or are you just skipping a step? Does it matter if A and B are steps?
No, it doesn't really matter. Skipping a step, I use this formula, part of the formula here.
Right.
Yeah.
But you could have started with that.
I could have started with this formula here, yes. And then solved for C. Okay? So I'm down to cosine big C here. All right? So now that I'm down to this, My top part here is a negative 0.09. My bottom part is a negative 63.6 equals cosine C. Now, how do I solve for C? Yep, inverse cosine. If you inverse cosine this, so cosine to the negative 1, that, you're going to end up with about 89.9 degrees. Yes?
So if we're the largest angle, was that just conveniently C? Like if it wasn't, then how do you do the equation?
You
Or
could,
do you just like take it and call it C?
you can call it C.
And this doesn't matter which was A or B?
Yeah, it doesn't really matter A and B. Okay? All right. Let's go to the next problem. There's a story problem here. We have the stars in Sirius and, I can't say the next word, Procyon, are first and seventh brightest stars other than our sun in the sky. One reason is that they are among the closest stars to Earth. Sirius being 8.6 light years away, and Procyon is 11.4 light years away. The measure of the arc between them in the sky is 12 degrees. Use this information to estimate how far away they are from each other. So on this one, you need to set up a triangle. So that's the first thing you would do. So let's do that. Okay, so on this one, I'm going to make this is the Earth. And one of them, Sirius or Cyrus, I don't know how you say it, okay, is 8.6 light years away. And P is 11.4. And it said the angle in between these two lines was 12 degrees. Okay, so I'm wanting to find out this length right here. Right? So we can just use the formula c squared. Let's call this c squared. Okay? Equals a squared plus b squared minus 2ab cosine c. Okay, so a squared, it doesn't matter which one you pick to be a. Which one do you want? Okay, 8.6 squared plus 11.4 squared minus 2 times 8.6. Well, I'm just, so I can use it in this formula, this is going to be x right here. Okay, so I just made it equal to c squared. Cosine, what's my angle? 12. Okay, so then we end up with c squared. If you put that all in your calculator, you should end up with 12.12. How do I find c by itself now? Square root. Yep, so I'm going to take the square root. So c ends up being 3.5 light years away from each other. Okay? All right, so for the law of sines, the formula for this one is sine big A over little a equals sine big B over little b and sine big C over little c. Personally, I like this formula the best because it's the easiest to deal with. You can do, you can solve these just like by cross multiplication. So this one's easier, but sometimes you have to use the law of cosines. If you don't have an angle listed, you do. Okay, so an example of this, here we got a campground, and we have the camp, we have a flagpole, and then we have the lodge across the water. And what they want to do is find F. How far is the distance between the camp and the lodge? Okay, so on this one, we can use big F and little f, okay? And we can use this angle, which we don't have. How would I find that angle right there? Yeah, 180 minus what? 150. Yep, because we're going to put those two together, add them together. So 180 minus 150 is 30 degrees. Okay? So we want to use this, oopsie. We want to use this with this one right here. Okay? So if I do sine F, oh, sorry, erase that. I'm going to do sine 40 over F equals cosine what? I mean, not cosine, but sine, what's our other angle that we're looking at? 30 over what? 400. Yep. Okay? So you're always picking the side across the angle, opposite of the angle. So now you can cross multiply and divide on this one, okay? So this would be, taking that one, it'd be sine 40 times 400 equals F times sine 30. Okay, so this side ends up being 257.11. And this side ends up being 0.5 F. How do I solve for F? Divide them both by 0.5. And then you end up being 514.2 equals F. All right, so on this one, we have a triangle called PQR. And the problem is they did not draw a picture of it for us, so we need to do it ourselves. Okay, so it doesn't need to be to scale. You can just draw a picture. I'm going to put it PQR. Okay, and it says length PQ is 7. So I'm going to put a 7 on that side. QR is 8. And angle P is 20. All right? It says find the measure of angle QRP and draw a picture of QPR. Well, we drew it already. Okay? So it wants to know R. We don't know what R is. So how would I go about finding that angle? Yep. Sine of 20 over 8. Yep. Yep. Perfect. Okay. So notice that 7 is across from R, so that's why it's matched up there, and 8 is across from 20. So cross multiply. You have 7 times sine 20 and 8 times sine R. Okay, so 7 times sine 20 is 0.2992. Oh, that's after finding it all, actually. Taking 7 times sine 20 divided by 8 already is this, okay? So now I got it down to sine R. How do I find for R? inverse sine. So it'd be sine to the -1 of 0.2992. And that would be, and I should do squiggle because it's an estimate, of 17.4 degrees. Yeah, I like the sine one better, personally. Okay, last one. Example 3. They have not made us a triangle. And this was a little different because you can possibly have more than one value. Okay, so let's look at this one. We have triangle ABC. Says measure A is, angle A is 35 degrees. AB is 8. BC is 6. Notice I haven't drawn this to scale. And it says find all possible values of C. It's the exact same problem that we did before, except different numbers, okay? So, sine 35 goes with what? 6. Okay, sine C goes with 8. So let's cross multiply that. We have 8 sine 35 equals 6 sine C. So sine C equals 0.7648 when you put that in your calculator. You inverse that. And you should have about 49.9 degrees.
Do you use the two equations interchangeably? Does it matter?
Yeah, you could have used,
One and this one?
yeah,
Oh.
sometimes you can use either one. Yep. Not always, but sometimes. The thing is about this. Think about how many degrees are in a triangle. 180, right? Okay? So, it's possible that I could take 180 and subtract 49.9 from it. And what do I get? I get about 130.11. So yeah, it's still possible that it works because you can add, if 35 plus 130.11 is less than 180, then that means this is a possible answer. So there's two possible answers for this, 49.9. Then if you take 180 to find out your other possible answer, make sure you add the two angles that you found, and if they're less than 180, then that's the other possible answer.
So are you just saying that it could have been that you came out with the other angle measure?
Yeah, it's just if you think about unit circle, this one's over here, and this one's over here, and remember sine is the same.
Okay.
Okay, so that's why it can be either one. Okay.